Example 6. You should try this one yourself before you watch me work through it, because it's pretty straightforward and follows the pattern you've been looking at. So turn off the lesson, do it yourself, turn it back on, and then watch me do it. Okay, a man starts walking north at a speed of 1.5 meters per second, and a woman starts at the same point P at the same time, walking west at a speed of 2 meters per second. At what rate is the distance between the man and the woman increasing 1 minute later? Okay, I'm just going to start here with the point P. The man starts walking north, so he's heading this way. This is the man, and he's walking at 1.5 meters per second. A woman starts at the same point at the same time and walks west, and she's walking at a speed, so this is the woman on this axis, at 2 meters per second. The question is, at what rate is the distance in between the man and the woman increasing 1 minute later? Okay, so we've got this distance right here in between them. Okay, so let's label this and set up a key. I'm going to let the distance from P to the woman be X, the distance from P to the man be Y, and the distance in between them is D. So let's just write that down. Let X be assigned the distance from P to the woman, and Y is assigned the distance from P to the man. Then D is the distance between the man and the woman. Okay, so looking at our diagram, I think it's fairly easy to see that we've got a right-angled triangle, which means we've got a Pythagoras x squared plus y squared equals d squared. First of all, let's get the givens in the equation written down. Okay, so what's given to us? Okay, so the man is walking at a speed of 1.5 meters per second. Y refers to the distance from P to the man. So I know that I've got this rate of change. The change in Y with respect to time is equal to 1.5 meters per second. And similarly, because the woman's walking at a speed of 2 meters per second, I know that dx by dt is equal to 2 meters per second. Then I'm asked to find the rate at which the distance between them is increasing. That is, what is the change in d with respect to time? There's my question. At what instant in time do I want to answer this? 1 minute later, when t is equal to 1 minute. Now stop and look at your units. These are given in seconds, and this is in minutes. Be consistent. I'm just going to change this to 60 seconds. Then, as we just discussed, we've got this relationship, x squared plus y squared is equal to d squared. So if I take the derivative of both sides of this equation implicitly with respect to time, I get 2x dx by dt plus 2y dy by dt equals 2d dd by dt. And I can simplify it because I could divide both sides of the equation by 2, and then you can see that the variable I'm trying to solve is this one right here. So dividing by 2 and rearranging, I get x times dx by dt plus y times dy by dt divided by d will give me dd by dt. then the information I need. I have dx by dt. I have dy by dt. I'm looking for this. What I don't have is x, y, and d. Is there some way I can get them based on what I've been told? Well, time is 60 seconds. The man walks at a speed of 1.5 meters per second. How far did he go in 60 seconds? So I could say that y is equal to 1.5 meters per second times 60 seconds, and that would give me 90 meters. Similarly, x, 2 meters per second times 60 seconds is going to give me 120 meters. So I've got x and y. What's d? Pythagoras. Once again, if x is 120 and y is 90, then d would be the square root of 120 squared plus 90 squared, which would give me 150 meters. Okay, so now we're going to take this information, the 90, the 120, the 150, the 2, the 1.5, and we're going to carefully plug it in where it belongs. That is, I've got x, 120, times dx by dt, times 2, plus y, which is 90, times dy by dt, which is 1.5, all divided by d, which is 150. This will give me the change in distance with respect to time. Simplify that, you're going to get 2.5 meters per second. So the distance between them is changing at a rate of 2.5 meters per second when t is equal to 60 seconds. Okay, I think that we've seen this before. Try working this through, just looking at velocity in terms of Pythagoras, and see if you can find a shortcut to answering this question.